Good afternoon to all my dear students. Now I'm taking the question number 5th, which is that show that if A is subset of B, means all the elements of A are in B, then C minus B. C minus B means all the elements of C which are not in B, and C minus A means all the elements of C which are not in A. Means C minus A means we have to remove all those elements of A from the C. This means, so let's see this question how to see. As we have given, let X belong to C minus B. X belong to C minus B means what? X belongs to C. According to definition, X belongs to C, but X does not belongs to B. X does not belongs to B, and we know already that in question it is given A is the subset of B, means all the elements of A are in B. If X does not belong to B, it means what? X also not belongs to A, because B is a big set, and in that B is the this is big set, and A is in the A. If B does not belong, it means automatically A is also does not belong to there, so we can write it as X does not belong to A. Now it means what? X belongs to C minus A. X belongs to C minus A. So from here we can see that this is 1, this is 2. We can see that C minus B is the subset of C minus A, and hence proved. So now the next question is as assume that power of A is equal to power of B. That means we have to show it is given, we have to show that A is equal to B. As we are doing what? Let X be an arbitrary element of A. Means X is what? It is an element of A is the set. So if X is the element of A, it means what? X is the subset of A. Why we are writing it? Because every elements are subset of a set, so that's why X is the subset of A. And then that means element X set X is also belongs to power of a set A. So it means X belongs to power of B. Why it is? Because already in the question it is given power of A is equal to power of B. So if X belongs to power of A, then X also belongs to power of B. So it means what? This implies X is also the subset of B. So from here we prove that X is the subset of B. So X belongs to B. Clear? The element X belongs to B, because set X belongs to B, X is subset of B, then X is also the belongs to B. So thus X belongs to A and X belongs to B. So A is the subset of B. A is the subset of B. And similarly we can take here, let Y be any arbitrary element B, and here the set Y is the subset of V, then Y is belongs to power of B, power of set B. Then Y is belongs to power of A, because reason is power of A is equal to power of B. Then from here Y is also the subset of A, and the element Y is belongs to A. So from here Y belongs to V, Y belongs to A. This implies V is the subset of A. So from here we can see that from first A is the subset of B and B is the subset of A. So it means A is equal to B, and hence it is proved. And the now next question is it true that for any set A and B, power of A union power of B is equal to power of A union B? We have to justify here. We have not to show. If we have to justify, we have to take here examples. So it is not true. This identity is not true. We can see that let A is the we have to take a set A as 1 and set B as 2. So A union B is 1 and 2, and power of the set A, power of set A is 5 and then set 1 itself, and power of B is power of B set is power of B is 5 and 2, and power of A union B, power of A union B, yeah, we can write here power of A union B. Power of A union B are 5, because 5 is the subset of all, then element 1, element B 2, and then set itself 1 2. So these are the power of. Now we can see here power of A union power of B, power of A union power of B. Now from here we can see that power of A union power of B is what? Power of A union B is 5 and set 1 and set 2. So from here we can see that the power of A union B is 5 1 2 1 2, and power of A union power of B is equal to 5 1 2. They are not equal, so it means from B we can see that power of A union power of B is not equal to power of A union B. Now similarly, using the property of set, show that A union A intersection B is equal to A, and A intersection A union B is equal to A. We have to prove this. So for that, see here solution: A union intersection B is equal to B. We will use again the distribution property A union A, then intersection A union B is equal to, as we know, A union A means union of these two sets is equal to A, and A intersection A union B. A union B means all the elements of A and B. If we are taking their intersection, then it means common is their A only, because this contains all the elements of A also and all elements of B, and we have taken only the A elements common, so A is outside. In the second, A intersection A union B is equal to A intersection A union, because of this sign, A intersection B. So again, A intersection A is A union A intersection B. A intersection B means all those elements of common of A and B. So elements of A and B common, so here A union